Hello, everyone. Welcome to another coffee chat session of my YouTube channel, Data Science with Sam. Today, we are going to discuss about another interesting topic that relates to data science field. A very emerging field as MLOps, or even you heard about ML engineering fields coming up in recent days. So what are those fields about and how these ML engineering fields fit into a data science criteria? So we'll discuss about that in today's coffee chat session. So I'm honored to present Aaron Blythe, who is actually the guest of today's coffee chat session. So welcome, Aaron. Welcome to the coffee chat session. I'm glad you joined us today. Could you please introduce yourself to our viewers before we get started with the questioning part?
Absolutely. Happy to be here. My name is Aaron Blythe, and I don't drink coffee. So for the listeners out there, whatever, you can drink Diet Coke. It's totally fine also for this.
Yes, you can pick your own beverage.
But like I said, my name is Aaron Blythe. I'm currently a customer engineer at Google Cloud. In my past, when I started off, I was what we call like an application developer many moons ago. And what that meant was like I wrote the applications at this healthcare company. And since then, I've had a number of different roles. And one thing that I got into was DevOps. And I got into DevOps a little bit out of frustration. I was like, there has to be a better way to do this, because I would, as an engineer, write a bunch of code, package it up and send like a zip file over to someone else. And then that engineer, she would like install it, or like I'd have to ask her for the logs or whatever. So it was out of frustration. I was like, well, there has to be a better way. So we automated that. And that was many years ago. I started the DevOps meetup, and then I did a DevOps days. And since then, I've done 4 DevOps days here in Kansas City, where I've gotten 500 of my closest friends together to talk about DevOps. But like I said, I got into that out of frustration. Now I've gotten into what I love, machine learning, out of like pure like joy. Like I love working on machine learning, and I love kind of the math behind it and everything. And the way that I met Sam is we both did a program for a master's degree at the University of Illinois that was just so much fun. And like, I got to meet all these incredible people and like hang out on Slack with them and like learn about things that like I just am so excited to do. So that's a little bit about me.
Thanks, Aaron. And definitely it's been a kind of like my pleasure to meet a lot of like exciting talents and exciting minds across the country through that program. So just for my viewers, me and Aaron, we're also alumni buddies. So we went to UIUC, we went to like an executive data science program offered by UIUC. So you should check it out if you want to pursue your career in data science. That's a very good program. And I think I talked about it in one of my YouTube vlogs. So check it out, or let me know if you need any more information about that program offered by University of Illinois at Urbana-Champaign. Having said that, so I'm going to dive into our question Q&A session today. So in the first question I would like to ask Aaron, given his background, he works in, DevOps field. Then after that, he grew his interest in the machine learning and the data science world. So I just want to have a very generic question for you, Aaron, and to start this discussion. So, like, given your recent academic experience at like UIUC, and also your work experience at Google. So what do you think about the key skills that a data scientist should possess? Like there are so many things we talked about data scientists, and they have to learn programming language, they have to learn a little bit about statistics. But if we want to like summarize everything, like say, what do you think like they're the most, I guess, 3 or 4 important skill set that data scientists should have in today's industry world?
So first, obviously, you kind of hit on this. You have to enjoy math. There's a lot of statistics. There's linear algebra. When I was doing the master's program, like I did a derivative for like the first time in 20 years. And I was like, oh yeah, I forgot. I love these things. So like the actual enjoyment of math, I think is kind of key. Like not just like you do it because you have to do it, but like I think that like people usually do better in things that they truly enjoy, right? So like having that type of stuff. Now that being said, the things I think you need are curiosity and open-mindedness. Like if you're willing to like dig into something and try to figure out like what's below the surface and like what's that next layer that's down, that's what I think like a lot of data science and just science in general really is being able to like ask that second, third, fourth question to really dig in. And for data science, I think that you need also like perseverance and patience. I have seen these quotes recently or like stories that like when you're doing science, what ends up happening usually is like it's somewhat boring. Like it's not, if you get results that are like in some way like surprising or wild, then it's very likely true. Like you're a lot of times you're finding things that you already know to be true. So it's that perseverance and patience. I know that like there's been different problems that I've gone through and I'm like, man, I've looked at this data like 80 different ways in 80 different directions, and like nothing interesting has like shown through. Like it's like, oh, okay, I've looked at the data this way, and it's like, oh well, I mean, there's a little bit of a grouping here, there's a little bit of a grouping there, but like nothing really to like write home about. Like, so you have to have that perseverance, you have to have that patience, and like just keep trying to dig to that next level deeper.
Yeah, I mean, I think you literally kind of make the point that it's not about like that how much knowledge you have. You always have to like build up on that. As I think data science is more of like a so emerging field, and so many things been going on around the world, and you always have to like keep yourself at that pace. So you actually have to have the curiosity or perseverance, as you mentioned, that, and if you don't have that kind of like a mindset, it's difficult to get into this new emerging field in data science. There's so many things going on. I mean, I know a lot of people have grew interest in mathematics, but they don't want to learn about programming language. But I feel like for data science, you need to have both of the skill set. You need to have knowledge in linear algebra. You also need to know how we can code your linear algebra or your regression formula in R or Python. So I feel like, like as you mentioned, that it's just like a curiosity, perseverance coupled with somebody's passion to learn more in mathematics or programming language field would definitely help someone to become a data scientist, or at least pursuing that direction. So, I mean, yeah, thank you for that feedback. But I hope our viewers will definitely agree with us. Yeah.
One other thing about the curiosity is like, and I think like also the enjoyment is like you have to be able to like really enjoy reading other people's views, right?
Yeah.
So like you can't go into things like with blinders or whatever. So like you have to read papers from other people that are going to have like different points of view than what your particular research is, or what the truth that you're going down. You have to like read them, and like if you don't have that like curiosity or enjoyment factor, like it's kind of dry. Like it's a slog, right? Like you're gonna go through and you're looking through all these different things. So actually being honest with yourself and saying, do I enjoy this? And like, am I curious enough to go after this? And like giving yourself pep talks. Like for me, like a lot of times I'm like, okay, I'm gonna have to dig into this like 40-page paper. I know there's a nugget in here somewhere that I really like. I know I'm gonna, okay, I just gotta make the time. So I did like all of the classwork, and when I'm doing like heads down work, it's right back here on this couch, like right behind me. Like I'll just go back there away from the keyboard, and I'll take my computer over and I'll just sit down and like really like put my bigger headphones on and really dig into it, because that's my time where like I try to get like like a 1, 2, or 3 hour like time period where I just kind of like dig in and I want to get super comfortable. So
no, that's really fascinating to know. I mean, I think my viewers would understand, especially some of them are already pursuing in the data science direction, that how crucial it is to like read through academic research paper related to this field. I mean, I from my past experience, I could tell that like 5 or 6 years back, I think I was not, I mean, I didn't spend a lot of time to read any academic research paper related to any, industry related innovation or science. But when I kind of started getting into this data science field, I started reading a lot of academics paper. And I remember that last year I was thinking of, writing a paper on deep learning related to healthcare or COVID-19. And there are tons of paper actually I had to read. And I think that's literally fit into that category of, like having that curiosity and perseverance and read more about other research, people's work, that will definitely, you can derive something from that, or maybe at least that will give you an idea that how you can, pursue or how you can actually, apply those previous work into your research. So I just feel like, as a data scientist, we need to have that mindset that's like a mindset of an academic person coupled with a mindset to drive like a business. It's like you've got to be in between the industry and academics. You have sometimes you got to actually put your academic hat on while you are going through the research paper, or try to think about something out of the box. I mean, don't you think so, Aaron? And I feel like that's how the data scientists would feel. Like they're like the position in between like academics and industry sometimes.
Absolutely. That's kind of like bleeding into the way that I see. I think the next thing we're going to talk about was, and I'll just like jump in because I'm super excited, like a scientist versus an engineer, right? Like, so this is the second time in my career. Like now we've got a lot of discussions about a data scientist versus a data engineer or ML engineer. And when I first got into my professional career, there was a lot of talk about like computer scientists versus engineers. And like I said at the beginning, like my initial job title was application developer. It kind of like split the middle. Like it was like, try to figure things out. So the big difference for me has always been that a scientist is that person that applies the scientific method. It's someone that's like looking for truth by hypothesizing and then doing some tests and trying to find like, something that they can actually consider to be like something that someone else can build on. So like building those building blocks through applying the scientific method. For me, an engineer has always come down to like the original engineer, like the
implementation part.
What's that?
The implementation part, like.
Yeah. Well, for me, like the way I think about it is like a train engineer. Like the engineer in the train was the person who was like, steering the ship, right? Like steering the train, but also would have to go and like shovel the coal into the engine to make sure that that like hungry engine like kept going. Like the engineer is the person that like has to do any and all the things to keep things on track. Like not literally for the trade engineer, it was like keep things on the track or whatever. Like when you came in and like you had to make sure that certain switches were pulled to go on the right track. You had to keep a schedule, like you had to like shovel the coal into the engine. So I've always thought of like my engineering career, even as a software engineer, as like it's not always applying like the scientific method or whatever, like maybe a data scientist or a computer scientist. So like computer scientists, when I was first coming up, like I always thought of them as the people that were building this awesome kernel, which was a building block that I would build my stuff on, or they build like the compiler that I'd write my C++ code in. But what I would do is like write that C++ code, or now it's Python in the data science space.
Yeah,
but I'd write the Python that keeps like my company on track, and not just on track, like also on schedule, also like, like moving towards something that like, whatever it is, like I've worked with for-profit companies and nonprofits, like there's always something that like we have as a goal. But I see my job as an engineer is like using these methods to keep things going. And that's not always just like writing the code. A lot of times that's like for engineering to be release engineering, like actually getting the code through a pipeline and out. And then for data engineering, it's getting the data in the right place. So as data scientists, like we spend so much time, like sometimes it's just asking for the data. Sometimes it's like getting the data and then we finally get it, but we get it on our laptop and we've got this CSV and we're munging that thing all over the place or whatever. If you've got a really good data engineer or a really good data engineering practice, you should be able to like leave the data at rest where it's at and be able to bring and do your data science on it. Like obviously I'm a little bit biased. I work at Google, but like we have BigQuery, which is like phenomenal. Like if you can use the data engineering bits to get the data there, then you can do your data science on it where it sits, right? And there's plenty of data warehouses that allow you to do this. But I feel like that's a really important practice of the data engineering, to get the data there for the data scientists to do all of the awesome things that the data scientist is doing. And then on the other side of that, you've got your ML engineer, which ML operations for me is a portion of like model operations. Like if you've got a really good data scientist that's creating some type of machine learning model that you can use for your business, like once that model is ready to go, that model needs to be put in some place. It's usually behind some type of API. So like say if you have some type of recommendation engine, if you're on an e-commerce website and you're recommending certain things, you've got to take that model and get it to production and get it to a place where when someone clicks on something in the website, that it's either addressing that model to say, okay, because they click this, or it's feeding the data back into the system to say, okay, because they clicked on this, we've got, we're going to build a better model for them next time. We're going to build a better model next time. And then the other part that the MLOps engineer really needs to do is get feedback, not just into that loop in the system, but feedback back to the data scientist. So the data scientist can say, okay, well, we built the best model based on what we knew today, but there's a couple of areas, some features that aren't being taken into account. So that data scientist has to say, okay, well, given what we know now and how good our model performed, well, now let's tweak this model. Let's build a better model for next time. So some of it's, that loop inside the system as the ML ops engineer, but also that's that loop getting things back, which is, like that's just kind of the way I've always viewed it. It's been this build up over years. I did my undergrad, I've always kind of felt like an imposter because I didn't do computer science. I did industrial engineering. But I felt the same way about manufacturing, is that like as a manufacturing engineer, and at the time it was weird. We were talking about lean and Deming and all the things that have come into computer science now, or software engineering through the lean agile type of movement. And I was talking about that when I was doing manufacturing years ago. I think we're on the cusp of where lean and agile are really going to become like an ingrained part into the data engineering and the ML ops that we're doing. So for putting the data scientists at the center there, I think it's really important that you understand these two pieces, bringing you the data and then making your models just like shine for the company.
Yeah, I mean, it's very interesting that you brought up a very, good, I think one of the best practice in the industry world, especially when it comes to data science world, that, data scientists also need to be plugged into that, I guess, that SDLC or like software development or that kind of a life cycle model. They also have to be plugged into the, I guess, DevOps or Scrum call, where they will be kind of like helping the ML engineer as a part of continuous integration or continuous development process, because no model is like foolproof. I mean, you have to basically continuously evolve to, make that model better, because we always face the challenge of, I guess, concept drift or any data drift situation, right? So a data scientist has to improve their model continuously. And while doing that, I think they really need help from an ML engineer to deploy the model in production environment on a, I guess, monthly basis or quarterly basis, I mean, based on their business practice. So it's so important, like, for a data scientist and ML engineer to work together. We discuss about what is the difference between those two roles. I think it's better, I guess, we can start thinking about how these two roles can, work together in a more coherent manner within like industry world. I think that's I guess the main essence of utilizing these two roles to their full extent for any business, whether it's big tech company or healthcare or retail or even finance. I think data science and ML engineer has a long way to go as a collaborative force. Okay, so that's kind of like I guess kind of brings me to my next question, which is kind of related to the same machine learning practice, but it's kind of related to a new term that people are using in the industry space that's called MLOps. So, I mean, the way I know about this field is like, it's kind of like, I guess, the combination of machine learning with DevOps practice. But I want to know more about this particular thing from you. I'm pretty sure my viewers will be very interested to know about this MLOps field. So Aaron, from your engineering background or based on your DevOps knowledge and expertise, so what do you think that the data scientists, I mean, do they need to acquire knowledge about MLOps, or they will always leave that particular responsibility on ML engineer? Okay, what do you think? What should be the best practice in future?
Well, I think the short answer is yes. I think that you want to at least understand the idea behind MLOps, but let's back up in case people aren't aware of what DevOps is. DevOps is this awkward word where like it's kind of a mashup of two words. Yeah. And the first one is dev, like development, and these are the people that usually write the code and then package it up into some kind of package like zip file, RPM file, or whatever. And then what they used to do is throw it over the wall to the ops or the operations. And there's another set of engineers, right? Mm-hmm. And what they do is they take that packaged up code and they run it on a VM or operating system or whatever. And a lot of times, due to like, I don't know, like the Tayloristic nature of businesses where everybody wants to create this kind of like supply chain, like similar to what like car manufacturing does. Mm-hmm. Yeah. And it doesn't really work. Like you want to be more aligned. So the DevOps idea was like, let's get the developers and the operations people like talking. Like we've got two sets of engineers here. When they talk together, they're going to do better work, right? And this has given rise to what I like to refer to as columns, which I believe came from Patrick Dubois in the term DevOps or whatever. But DevOps is culture, automation, either lean, the L could either be lean, technology, or learning, measuring, and sharing, right? Like, so it's partially a cultural type of movement, but it's also a technology movement in that like you automate things. Yeah, you want to automate things, but you also want to measure them and have a feedback loop. So I already went into this, like for the MLOps, right? You want to automate getting that model that's been created by the data scientist out behind a REST API so that it can be used by the rest of the software engineers. But then you also want to measure. You want to have some kind of feedback loop that brings things back in. So the other thing that's happened from the DevOps movement is many times done right, companies will like reorganize how they deliver their software, right? So instead of having this thing where you've got 50 engineers over here writing code, and they get to the point and they package something up and throw it over here to 50 engineers over here, and they run the code or whatever. Some companies like streamline this and say, if you write it, you run it. There's a number of different companies, like you can just kind of Google that phrase, like if you write it, you run it. And you can see like how different companies have figured out like how they're going to do this. Now, I'm going to probably say her name wrong, but like on martinfowler.com or ThoughtWorks, there Zhamak Dengani, and I'm probably just saying it wrong, and I really apologize. But in 2019, she wrote a paper on data mesh. Now, and then there's a follow-up paper in 2020, and they are incredible. They talk about all kinds of things about like why a data mesh or data fabric is the way to go. So we all know about like data lakes are where we're going to put our unstructured data, and a data warehouse is where you're going to put your like more structured data. And that could be like inferences. So unstructured data is going to be things like images or documents or like big blobs of data. And then as a data scientist, you might like make inferences from those things, and then you'll put those into a data warehouse, right? So very similar to the DevOps world. This data mesh idea kind of has that MLOps built in, where you want to kind of restructure your company. And maybe instead of having, a whole team of data engineers here, they're going to get the data over to the data scientists, which is another team here, which are going to then have to wait for the ML engineering team over here. Like, so say we've got say we got a group of 3 people here, 3 here, and then 3 in the third group. Like, what if we cut it the other way? What if the teams were like, what are we trying to do for the business? Like maybe we have the recommendation team or whatever, and that team is made up of a data engineer, a data scientist, and an ML engineer. And the 3 of them are the team, and they actually flow through the system that important data. When you start to think about things as what functionally you're doing for the business, like that's when you start moving faster. In the DevOps world, we have like a very key piece of literature which comes out every year, and it's a survey where it's the State of DevOps report, and it's done by a group called Dora. And they go and they ask all these questions of all kinds of companies, and they figured out a way to say, of the respondents, which of the companies are doing really well in the market. And they put things in segments of like high performing and medium performing and lower performing, as far as like, market cap and a number of different things. And the group that does the high performing, there's certain practices that they do. And one of the biggest practices is making sure that they do CI and CD, which is what we refer to as continuous integration and continuous either delivery or deployment. Right. So continuous integration means that like every time you check in code, that code is tested and all the tests pass before it's packaged up. And then continuous delivery is every time you have a new piece of code that's passed all the tests, then it is ready to go for everything other than switching over into production, right? Continuous delivery, you still have someone that presses the button and says, we're good, because a lot of people are scared. They're like, what if I passed all my tests, but I didn't have very good tests or whatever? But continuous deployment goes all the way. Like you test the code, boom, it just goes through your pipeline and you just deploy it. Now that's a bit much for most people. Most people do what we call continuous delivery. And I think that that's what we're kind of working towards in the MLOps space. I don't know that I've seen a company that's just like got this down pat. So you talked earlier, I think about like there being like, I don't know, like a lot of jobs in MLOps right now. And I think that's what you get to do. Like this is where you get to actually, as an MLOps person, you get to do a bit of science, because you get to test out things and see what works.
You have the subject matter expertise. Yeah.
It's a little bit of art right now, because it's not pure engineering. It's not like just saying, okay, I'm going to take this software package that delivers my model. Like, now, by all means, you're going to use things that we've learned from years of being like, DevOps and delivering our code from left to right. So you've got, a wealth of things to read. But again, this is a situation where like, it's almost like you're reading all the things we did in DevOps as though they're research papers, and then applying them in a scientific way to say, I bet this would work for this model. Like, I bet I could get this out to the right place. But then there's a little bit of nuance here, because it's not just deploy. It's like deploy in such a way that you can get those feedback loops, which we've done in many ways for years in DevOps. Like, we've gotten feedback on, I know that people A/B test their code. If they have like a strong enough pipeline to get their code out, they're like, okay, here's my A and here's my B, and I'm going to give each of them to 50% of my customers. Oh, this one, A is outperforming. We're going to give everybody A, but you have to have a pretty sophisticated pipeline to be able to do this. I think that MLOps is like, we're just going to learn all kinds of things from DevOps. So,
yeah.
So back to your original question. As a data scientist, do you need to know MLOps? I don't know that you need to be able to hands-on keyboard do every single little bit that your MLOps person is doing, but I like that idea of being a tightly knit team where you know the virtues of what the data engineer is doing to get the data to you, and you know the virtues of what the MLOps engineer is doing to get the data to your customer, or get the model actually to your customer. And like understanding that in an integrated fashion, like you have to be able to speak that language and understand those pieces. And it's so much better now, like instead of like what it's been for years for a data scientist to simply like, beg for the data from somewhere else in the company. Like you spend a lot of time doing that. Now you can spend time actually talking to an engineer about like, okay, what if we did the data a little bit different here? You had it in this way so that I could actually make this model perform better. Oh, well, that's a way better conversation than one where like you're like, oh man, I've been munging this silly thing in a CSV on my machine forever. So if you get a good data engineer, you're freeing up time to have better conversations. So it's worth putting in the effort to understand what a good data engineer should do, or what a good data engineering practice is. And it's good to put in the time to understand what a good ML operations practice would be.
I feel like these roles kind of like literally switch their place in between, because as you said, like the ML engineer, it's not their job just to deploy a model. For them, they also need to understand the underlying maybe statistics, or maybe they should have some expertise to evaluate the model. Maybe they should have some understanding of what confusion matrix is, how they can perform sensitivity or specificity test. So I feel like, as a data scientist, they can also like, switch to an ML engineer role, or, they can, an ML engineer could be a data scientist role, given how much knowledge they have in terms of statistics or mathematical space, or maybe the programming knowledge. So I feel like, like this data scientist and ML engineer, it's not like that one person has to fill that two spots. Rather, they can work together to build a team. So if somebody, like in my view, or if they're a data science manager, I would definitely recommend them to hire both data scientists and ML engineer, rather than having one person to both the jobs. And I think that's what, Aaron, you were also trying to, mention over here. That it's good to have a coherent force between data scientist and ML engineer, rather than having someone to do the model development and model deployment work together.
Yeah, I think it's separating the role. Like sometimes it can be, it's not without the realms of possibility that it would be the same person. And I think that like a good unit, if you cross train over time, and I found this to be true with DevOps also, is coming from a developer background, I was working so closely with the operation groups that I was learning the job that they did. And at the same time, I was also teaching them how to use, I think for the DevOps movement, Ruby was like the tool of choice. It was, like Python seems to be for the data scientists, but for the DevOps. So I was teaching quite a bit of Ruby to operations people. And like the clear separation blurs as you get a really good unit and you start to do things together. So say the person's out on vacation or whatever, and you're like, oh, well, I know the things that they do. I think I could actually in crisis mode, I could step in and do those type of things. Or you get cross-trained so well that it doesn't even take a crisis. Like you're simply like, I trust you because I've taught you. Like, I think it becomes, if done right, whether it's DevOps or MLOps, it becomes like a mentorship type of role but it's a bi-directional type of mentorship type of role. It's like, I, as a professional, know how to do this particular job really well, but that's not something I need to protect you from ever doing. I can teach you every bits of what I do. So you kind of become a mentor and apprentice in both directions. And I think that for me personally, those have been the most satisfying relationships I've had in my professional career, is one where I don't feel like I'm only teaching someone else, I'm teaching them, but they're also teaching me. So like it goes kind of both directions where,
Yeah,
yeah.
exactly. I mean, that's very fascinating, because that's the thing, like it's kind of taking us back to the beginning of this discussion, that curiosity and perseverance, it goes in both ways. Like it's not about like a mentor could learn a lot from their mentees as well. So it's really fascinating to know that, like so much we still need to learn. And when you talk about data science and MLOps, I mean, we can literally talk about that all day, but like we have limited time. But yeah, it's literally kind of like this MLOps field would change the paradigm of the data science field of study. I mean, it definitely give us that kind of a flexibility where a data science could be like an applicable, and it could take that field of artificial intelligence or machine learning to the next level. Because more we continuously evolve when we want to develop our model, the better we are in terms of achieving better accuracy for any kind of prediction, whether it's a financial forecasting or house price, or even Netflix movie recommendation, or any prediction that Google is currently working on. I mean, they can get benefit from this MLOps pipeline every day. So yeah, so that's kind of like brings me to the end of this particular question and answer section. So any final remarks to my viewers, especially would like to pursue their career in this data scientist or ML engineer direction? Any final tips you would like to share with them, Aaron?
I'd say be curious and like find something that like you're passionate about. Like the cool thing about science, and especially data science, is like it can be applied to anything. We talked about recommendation engines at Netflix or whatever, but there's also like a lot of insurance really cool things with like trying to find fraud or whatever. There are like just anything you can think of that data science can be applied to. So be curious, but also find something you're passionate about. Like there's more than enough problems to solve that like you should be able to pick one that you care about and do things. And by all means, reach out to me. I'm on LinkedIn. I love to have these type of conversations with any and everybody about like where their interests lie and how I can help them out.
Thanks, Aaron, and it's a pleasure talking to you on this very interesting topic. And for my viewers, I shared Aaron's LinkedIn link in the video caption. So please feel free to connect with him if you have any question related to data science or ML engineer, or if you'd like to know more about what kind of innovative work Google is doing and what Aaron has been up to in recent days. Feel free to connect with him on LinkedIn. And also please share, check that video caption. I share some other links related to what MLOps is or data science. So you will get more information from those links as well. So again, it goes without saying, like thanks Aaron for your time and consideration. And I think it's a great chat. I'm pretty sure my viewers would get benefited from this discussion, and they would get a lot of like information about what is data science or ML engineer or MLOps field. So thanks, Aaron, for joining our session. And for my viewers, I'll see you for the next Coffee Chat session. Keep subscribing to my channel as more contents on data science, MLOps, AI, artificial intelligence, and machine learning are forthcoming. That's all for today. Thanks, Aaron. Thanks for your time.
Thank you.